day 2, so I am going to ask you guys to put your Chromebooks up because we do have some examples we want to get through, and then after I'm done, you guys can learn. Alright, so we've got quadratic formula for the second day. Now, just like we did yesterday, what does our equation have to be equal to before we do the quadratic formula? All right, it's got to be equal to 0. And we always like to put our equation in the order where we have the x squared first. And so the coefficient with x squared is what we always plug in for a. And then we like the term with the x, and the coefficient there is b. And then we put the constant number that doesn't have the variable, and we want it to be equal to 0. And then once it's equal to 0, we can do the quadratic formula. So help me out. Try to tell me without looking, but if you need to look, that's okay. How do we solve for x? What's the first part of the formula? Negative b.
Plus or minus. Parentheses.
Square root. Now what goes inside that square root?
B.
And what do we know about b squared? What kind of number will that always be?
Positive.
Positive.
And minus 4 AC.
Times a times c. And then what always goes in the denominator?
2A.
2a. So we are going to plug in all of our numbers into the formula. The only thing that we're going to see different today is what's inside the square root is not going to be a perfect square. So we aren't going to see square roots like 25 or 36 or 100 today. We're going to see things that have to be simplified. So like 40, 120, different things that you can simplify and we can reduce, but we just won't see anything that's perfect today. So the first example I want to do, 2p squared minus 2p minus 16 equals 0. All right, so on this one, what am I going to plug in for a? A is 2. What about b? Negative 2, and c? Negative 16. So I'm just going to write a, b, and c here. So I'm going to plug in what I know. All right, so I always put parentheses around what I'm plugging in. So it tells me that there already is a negative in the formula, but what am I plugging in for b? Negative 2. So this negative came from the formula, this negative came from the equation. And then inside the square root, I've got b squared. So b is negative 2, and we're going to square it. Minus 4 times a times c. All right, what number am I plugging in for a? What am I plugging in for c? Negative 16. And then my denominator is 2 times a, which ends up being 2 times 2. All right, before we simplify, if you have any questions, I don't want you to not ask, because honestly, getting everything in the right spot is key. And now we just have to simplify. So the formula will always be given to you. On the quiz on Friday, I'll have the formula up on the board. No question, you'll get access to that. So now we need to simplify. All right, what can you guys tell me about these two negatives? What do they turn into? Positive 2. That's why I actually always refer to the formula. Instead of saying negative b, I usually say the opposite of b, because whatever b is in the equation, it's always going to flip-flop the sign. And so when you see a negative here, once you simplify the equation, it will turn into a positive. Now, inside the square root, what's negative 2 squared? 4. Now, let's do some multiplying. Negative 4 times 2 times negative 16. What is negative 4 times 2 times negative 16? You know, say, you guys aren't talking loud. I really can't hear you.
128.
128, is that a positive or negative? All right, it's a positive 128. And then 2 times 2 is 4. All right, do we all see where those two negatives become the positive 128? Now, if we add the numbers inside the square root, because that's what we always do next to simplify, 128 plus 4 is 132. So I'm just going to write that off to the side because I don't like to rewrite all my work again. But 132 is not a perfect square. You say, didn't we just do an entire week of simplifying square roots? You say that was the whole point. So if this isn't a perfect square, we are going to simplify that. So this one we do have to simplify. And it's an even number, so what do you want to start dividing by to simplify it? Divide it by 2. All right, 132 divided by 2 is that right? 66? All right, divide that by 2 again. What do I get? What can I divide that by? All right, I divide that by 3 and I get 11. And then 11's prime, so we divide that. So we do have a pair, so it was helpful to simplify because we can now pull out a 2. So instead of writing square root of 132, how do I rewrite that? 2 root 33. The pair goes on the outside, the leftovers that do not have pairs get multiplied back in the inside of the radical over 4. Now, like we talked about on Friday, we've already reduced the root, so we don't worry about that square root of 33. But look at the coefficients. Do 2, 2, and 4 all have something in common that we can reduce by?
2.
All right, so these here we're going to reduce. So if I reduce that by 2, what does this number become? 1 plus or minus, what's this 2 become? And then I divide it by 2. And we always leave it as one answer with that plus or minus symbol. So we're essentially not learning anything new today. We already know how to simplify the square roots and reduce. We already know how to plug things into the quadratic formula. We're just taking the things from Friday and Monday and putting those together. So some of your answers will be able to reduce. Some of them, once you do the cake method to simplify, sometimes the coefficients have nothing in common, and then you can just stop. It depends on situation to situation, but I actually have one that I want to show you for this next part. Let me see if I can, there we go. It looks a little bit different, and we haven't done anything like it. So, let's see what we have. Now, I want you to know, this is not a typo. All right, what part are we missing? All right, we're missing a b. That's okay. Now, is our equation equal to 0? I said, what do we need to do to that negative 5? All right, let's add it over. And it doesn't have a variable, so we can add it right to that negative 7. So we're really solving 10n squared. Now what's negative 7 plus 5? Negative 2. So we are missing a number. We only have two numbers.
So
B equals 0. So on this one, our A is 10, but since we are missing our term with just an N, our B is 0 and our C is negative 2. So if you are missing a number, you'll never miss an A. You have to have the squared term to do the quadratic formula. But if you are ever missing a B or a C, you just plug in a 0. All right, so for the formula, all right, we're plugging in everything. All right, what am I plugging in here? 0. What do I plug in here? Here? 10, here, and here. All right. Now what would negative 0 be?
just 0.
Just 0. Now it is important to leave it there, because if you add and subtract something from 0, you get different answers. All right, now inside the square root, what is 0 squared?
0.
0.
Minus 0. Oh, maybe plus 0.
So, well, hang on. What's negative 4 times 10 times negative 2?
Oh, I'm sorry, I didn't see the 1.
It is positive 80 over 20. So we need to simplify 0 plus 80 is the square root of 80. We need to simplify that. Now, it's even. So what do I want to start dividing by? We're going to divide by 2. That gives me 40. Divide by 2. That gives me 20. Divide by 2. That gives me 10. Divide by 2. That gives me 5. And then I can divide by 5. So I have 2 pairs of 2's here. So I have 0 plus or minus over 20. Now, how do I rewrite the square root of 80? 4 root 5. So my first answer would be with a plus. 1 would be with a minus. Now, if you add 0 plus something, that's a positive number, right? 0 minus something is a negative number. Now, on this one, it can be reduced. What can 0, 4, and 20 all be divided by? We can divide it by more than just 2. Yeah, we can actually reduce this. And so what's 0 divided by anything? 0 plus or minus. Now the 4, if I divide that by 4, that's just a 1. Now you can write the 1 with the square root, but it's not necessary. Now what's 20 divided by 4? 5. Now the 0 at the very end, you can leave it like this, or you can just say plus or minus root 5 over 5. Because this adding the adding and subtracting 0, you can leave it either way. That's totally up to you. So we've got a positive root 5 over 5 and a negative root 5 over 5. So we do have 2 answers there. But I wanted to make sure we didn't do an example yesterday where we had a b equals 0. But just remember, if you are missing one of the numbers in the equation, just plug in a 0. Sometimes it's b, sometimes it's c. Now, I actually have one that I want you guys to try on your own. And it's not going to be equal to 0. Feel free to talk to people next to you, see if you get the same answer as they do. I've taken all my markers back. 2a squared minus 9a minus 7 equals negative 6. Say, do you guys need more time? I'm gonna say these are the ones I like. So, first of all, you guys did add 6 over to the negative 7 first. See, you guys did make it equal to 0 first, right? So then that becomes 2a squared minus 9a, negative 7 plus 6 is negative 1. I'm going to skip some steps if that's okay. What do you guys think about that? So whenever I plug in a negative 9 at the very beginning, the two negatives do turn that into a positive 9. Negative 9 squared is a positive 81. Negative 4 times 2 times negative 1 would be a positive 8. And then 2 times 2 is 4. So do you guys have any questions on that, getting those numbers? All right, so when you add those in the square root, we get 89. What kind of number is 89? Anybody know? So did you guys try to simplify 89? Did you find a number that you could divide by? No, that's a prime number. So 89 is prime, so there is absolutely no reducing possible. You are done. No reducing possible on that one because 89 is prime. All right, we are almost done. We've got 2 more. Now on this one, I'm actually going to show you guys just a little way to shorten up your work just a little bit. All right, we want this to be equal to 0. What are we going to do to that 8x? All right, subtract it. Now where do we want that x term to end up? Do we want it on the end or do we want it in the middle? All right, so if you know you're going to subtract it, is it okay just to make it a minus 8x over here? Do you think I'm okay, as long as you're showing me that you're moving it? If you don't want to write minus 8x to both sides, if you just want to move it over, I'm okay with that. Now, what am I going to get when I do this? All right, so 2 negatives would turn this into a positive 8. Now, what do I get for negative 8 squared? 64. Now, negative 4 times 2 times 2. What does that give me? Negative 16. And then 2 times a? 2 times 2? 4.
When we do our test or our homework, are we allowed to skip that step? Or do we have to-
So you're asking me, can you go from here to here?
Yeah.
Absolutely. Absolutely. Now, I will tell you guys, in my Algebra 2 class, they do this. They just quickly, they write it like this. Do some mental math. They at least keep track of it before they plug it in. But you don't have to do that. But if you guys are comfortable with doing some of those steps in your head, I'm okay with it. Just be very careful on the negative 4ac not to lose signs. So what is 64 minus 16? We gotta simplify it. 64 minus 16. All right, so we are going to we have to simplify that.
You can divide all that through.
Well, this is inside the root. We got to.
Oh.
Yep, we have to get some coefficients out first, and then we'll reduce it. So if you divide 48, it's even, so divide that by 2. What's half of 48? All right, that's still even. What's half of 24? Half of 12. And then half of 6 is 3. And then we divide by 3, we get 1. All right, how do I rewrite that?
4, then 1, 3.
All right, 4, and the radical is 3. Now can I reduce everything by 4? All right, so what is 8 divided by 4? What's 4 divided by 4? All right, now, do I have to write 1 root 3, or is just root 3 okay? And then what happens when I divide 4 by 4?
You don't have to write it.
You don't have to write, you can write e over 1, but that's we don't have to put that if your denominator is 1. You can be done. I don't know, I think kind of in a way, when they're not perfect squares, it's a little bit easier. There's less work to do, I guess. Now, my final example for today looks like this. All right, now this is not equal to 0. So we have some options. We can subtract the 11n squared over to the other side, to the right-hand side, or we can, anything that's on the right, we can move it to the left. It does not matter as long as they're all on the same side. So do you guys want to move this 11n squared over and make it negative, or do you guys want to move everything? It really doesn't. I'm going to say, what did you say, Mallory? You're going to say, this is just a personal preference. I like my square term to stay positive. So if I have this 11n squared. What's going to happen to a 7n if I subtract it over? Negative. It'll be a negative 7n, and then what happens to a negative 4 if I add it over? So if I move them over, they're going to switch signs. All right, so let's plug in what we know. What happens when I do a negative of negative 7? All right, that's just 7. Now, inside the square root, negative 7 squared is 49. Now, let's get calculators out. Negative 4 times 11 times 4.
176.
Positive or negative?
Negative.
And the last part, 2 times 11. All right, so we have to simplify what's inside the square root. What is 49 minus 176? It's a negative 127. Now, what do you notice about this problem versus everything else? What kind of looks different on this one versus all the other ones? All right, there is a negative inside the square root. So for all of you that have calculators with a square root button, your phone even will do this as well. Everybody try to take the square root of negative 127 and tell me what it gives you. Square root.
11.26.
Oh, did you plug in a negative when you did that? Is there anything in your window besides a 0, like in the corner? There's an E. All right. Caitlin says math error. Mine says error, non-real answer. All right, let's think about this for a second. Square roots are telling us we're trying to find a number that when you square it, it equals that number. What do we know about two negative numbers? What do they multiply to? What's a positive times a positive? All right, is there any way that we can have a number times itself, regardless if it's positive or negative, ever be a negative number?
No.
So, this is a red flag, and it actually exists. So, if you have a negative square root, that's not a real thing. It's a non-real answer. In Algebra 2, you actually learn about something called imaginary numbers, and you do work with negative square roots, but we don't in Algebra 1. So if you have a negative square root, this can't happen. So if we cannot get an answer, what do we write whenever we don't have an answer for something? Where are you thinking, Gracie? You wouldn't put 0. That's a good thought. It's no solution. So 0 is a number. 0 could be an answer. So if you have a negative square root, that's a no solution. Now, that's why you have to be very careful with your signs, because if you miss a sign on your negative 4AC, like right here, if you had forgot a negative and didn't make that a positive, that could show up as a no solution. So make sure you're being super careful about your signs, but if you do have a negative square root, it is a no solution. And as you guys are working, if you guys really want to know if an answer is a no solution, feel free to ask. I can tell you if you're missing something. So you guys do have an assignment over this today. I can't remember how long it is. It's been like over a week since I uploaded it to Canvas. Yes, you can still do that on paper. And don't worry, like it says that the assignment's due Wednesday night at midnight, but if you're not going to be here tomorrow, so if you bring in your paper on Thursday, it's totally okay.